some learner decides to investigate the relationship between the observed frequency and the frequency of sound waves emitted by a stationary source. The learner moves towards the source at a constant velocity. So we have the velocity of the listener being constant, right? Let's call it x, and then the learner records the observed frequency FL for a given sound source frequency. This process is repeated for different frequencies of the source, with the learner moving at the same constant velocity for each time, right? The graph below shows how the observed frequency changes as the frequency of sound waves emitted by the source changes. And then we have a graph there which we're going to talk about in a moment. But the first question, 6.1. So 6.1 is saying that let's name the phenomenon illustrated by the graph. Question 6, grade 12 physical sciences. If the question says name the phenomenon, it's always Doppler effect, right? So that's the answer for 6.1. We have Doppler effect, right? Let's move to 6.2. So 6.2 is saying that name one application in the medical field of the phenomenon in question 6.1. So that's we can write ultrasound, right? That's one of the applications of Doppler effect in the medical field. And then 6.3, write down the type of relationship that exists between FL and FS as illustrated by the graph. We can see that they are clearly directly proportional to each other, right? As FS increases, FL increases. So we can say here that they are directly proportional to each other. Right? If you want to go further, you can even say that as FS increases, FL increases, right? Yeah, but then it's just 1 mark, so this will be sufficient. But then if for instance it was for 2 marks, then you would say that as FS increases, FL increases. Now let's solve the problem. 6.4. So 6.4 is saying that 6.4 in blue, not in purple. So 6.4 is saying that the gradient of the graph obtained is found to be 1.06, right? If the speed of sound in air is, so we have v of sound in air is 340 meters per second. Calculate the magnitude of the velocity at which the learner approaches the source. So we're given the gradient of the graph, right? And so what we're gonna do here, we're gonna look for the equation of the graph so that we can know what the gradient is and find a way to solve our problem, right? So we know fully well that in Doppler effect we have FL being equals to V plus or minus the velocity of listener divided by V plus or minus the velocity of the source, everything multiplied by the frequency of the source, right? In our graph we have FL being the Y, and then we have FS being the X. So this expression here will be our what? Yeah, just like you guessed, it will be our M, right? So if we can take that expression then, and then we can equate it to 1.06 because that's the gradient. So what are we saying? We're saying that V plus or minus VL divided by V plus or minus VS should be equals to 1.06, right? It's not me, it's the question. So now we can substitute our values and solve for VL, right? We're looking for the velocity of the listener. So that V, this V here is for the sound in air, right? So we're gonna have 340. So because we are told that the listener or the learner is moving towards the stationary source, right? Then you must have plus VL, right? And then divided by 340. The sound source is stationary. So we're just gonna have plus or minus 0, which is just 0, and this will be equals to 1.06, right? 1.06 is the same as 1.06 divided by 1. So if we cross multiply here, we should get 340 plus VL being equals to 340 multiplied by 1.06. So here it should be easy to see that VL will be equals to 340 multiplied by 1.06 minus 340, right? So VL should be equals to 20.4 meters per second, right? And that's how we solve that problem basically. Now let's do the last problem, 6.5. 6.5 is saying that the investigation is now repeated with the learner moving at a higher constant velocity toward the sound source. Copy the graph above in your answer book and label it as A. On the same set of axes, sketch the graph that will be obtained when the learner is moving at a higher velocity. Label this graph B, right? So this one, they're saying we must label it A, right? And we must draw a graph for when the learner is moving at a higher constant velocity and label it B, right? So let's see what the consequences of a higher constant velocity will be. So we know that we have the gradient being equals to V plus VL divided by V plus or minus 0, basically, right? This is what the gradient of our graph is. But then now the learner is moving at a higher constant velocity, right? So it will be easy to see that if VL goes up, right, the gradient should also go up, right? So for your graph B, you have the same straight line, but then the gradient is just slightly steeper than that one when the learner is moving at a less velocity. So we're going to have our graph here, right? The gradient is just a bit steeper, right? Just steeper than A, and then we label it B.